participation of some of our programs. We are currently celebrating Hindi Pakhwada. Our games are going on, and there are many other things. We keep organizing such lectures where distinguished scientists, academicians, technocrats, or scientists, national, international, we keep them inviting whenever we get opportunity, because this is the platform where perhaps they can get motivation by interacting with those scientists or by sharing their life experiences. Uh, as we all know, because science and technology, they are very, very important for our development, what do you call the for the country as well. Now innovation is also included in that, and nowadays we are talking a lot about that science. India should be hub of many many things because of economic scenario, or maybe due to international conditions, and we want to make many things or develop science, technology, innovations for India and for the world. We want to be manufacturer hub for many, many electronic components. You perhaps cylinder, this silicon chips and all that. We are semiconductor chip. We are trying for that. So now the question is, can we do that? Can we do that? So if yes, how? If no, what are the deterrent? What are the hindrance? For that all, we are going to listen today from Professor Sivanand Kanavi. I will introduce you briefly, and before that, maybe I can. This his talk will focus on challenges in developing science and technology in India, for India and the world, which is the topic which you can read here also, and he will try to justify it by inspiring some examples which you must listen, because those who have done already something, their stories, for like in our innovation hub, if you come, you will listen to many many stories, whether they are accidental discoveries, whether they are innovative, whether intentional, or so that process, if you learn, that will give you a lot of motivation to you, all of you. So for this, as I told you, we have with us Professor Sadanand Kanvi. I will just briefly introduce him. Professor Sadanand Kanavi is a theoretical physicist, and I think just listen it carefully. You will get a lot many things in this. He's a theoretical physicist, author, and former vice president of Tata Consultancy Services, popularly known as TCS, with a background in quantum physics. Those who are from physics background, I'm also from physics background, so I can understand. Quantum physics and elementary particles from IIT Kanpur, Northeastern University, Boston, USA, and IIT Bombay. He initially pursued an academic career in research and teaching. He later transitioned into economic consultancy and then business journalism, serving as the executive editor of the pioneering Business India. That's a very popular magazine. In 2004, he joined TCS as vice president, heading strategy, marketing, and branding projects until 2013. Uh, Shri Kanvi is the acclaimed author of Send to Silicon, the amazing story of digital technology, which received high praise from figures like former President Dr. APJ Abdul Kalam. He has also edited a book on innovation at TCS, Research by Design, Innovation, and TCS, and a knowledge commentator on India's IT, space, and nuclear program. He is a recipient of Madhu Velori Award for Journalism and is currently an adjunct faculty at National Institute of Advanced Studies in Bengaluru. He has written extensively on business, technology, Indian economy, history, and darshan. He is a very popular speaker in IITs and many universities and colleges, as well as on radio and TV. This is, I think, second visit for Professor Kanvi to the in this auditorium. Yesterday also he has delivered a lecture at Vidya Alankar. So when he was here in Mumbai, we thought we can wrap this opportunity and we can present it to school students so that they can get also motivation. So with this brief introduction, I will request Professor Kanvi to come on the stage, and I will request all of you to welcome him on the stage. I'll also request our young budding scientist, Mr. Rohit or Master Rohit from Shri Vardhman Vidyalaya. Yeah. To welcome Professor Kanvi on behalf of all of us who have been with our 14th class. That's how we welcome our guests. Thank you, Rohit. And now, those who are present online also, as Professor Kanvi has told, the lecture will be mainly in English, but question answer at the end we can have. He would like to have more interactive session, so we have kept more time for question answer, and that can be in Marathi, Hindi, English, three language opportunity you have. Okay, so get ready. Sir, over to you, and now stage is yours.
Good morning. From the uniform, I met a few children outside. So I think many of you are from Little Flower School, Andheri Mahakali, right? What other schools and colleges are you from? What other institutions? Are only all from Little Flower? Which other colleges and schools you are from? Can you just Bombay Teachers Training? Okay. And any other? Excellent. Vardhaman Vidyalaya, where is it from? Thane. Very good. Excellent. Okay. So, first of all, I want to thank National Center for Science Communicators and my friend Suhas Naik Satamji, and of course Nehru Science Center and Umesh ji and all the staff and faculty here at the Nehru Science Center for giving me this opportunity to interact with all of you, because you are the future of India's science and technology. We are all the past. We are writing history, we are writing books on that and what happened in 1890s, before independence, after independence, what happened in the 60s and 70s, what happened with the digital revolution and all that. For you, digital revolution doesn't make any sense. You don't understand what is digital revolution because you have not lived through what was before and what went on during the revolution and what is happening now. All you see is what is happening now, right? So if I start telling you that when I went to United States in '74, from after finishing my degree in IIT Kanpur, to make a call to America, to either to my university or anybody else, I had to come to Central Telegraph Office in whichever city I was, book a call, wait for 3 hours. That was called lightning call, and 3 minutes used to call 160 rupees at that time, and my entire scholarship with which I was staying in IIT Kanpur was 150 rupees per month. And one call, 3 minute call to United States used to cost 160 rupees. And half the time you used to spend saying, "Can you listen to me? Can you listen to me? Can you hear me?" And meanwhile, operator will say, "Time ho gaya, sir. Continue karu ke cut karu." That was the situation. So we used to send telegrams. In fact, I got delayed to go to United States by about a week. So I had to send a telegram to them saying I'm coming 1 week late and so on, because then even then I was not sure whether the immigration will let me in or not. So I had taken a return ticket and gone. And anyway, so what I'm saying is, for us, those computers we saw in IIT Kanpur. First time I learned computer programming in 72, 73 on mainframes, and how we used to punch cards, how we used to wait 24 hours to see whether our program works or not. Okay, and 24 hours के बाद हमको result मिलता था syntax error. Okay, so one line, some code was wrong, so and so on. You have no clue on what was computers at that time. You have no clue what was telecom at that time. You no clue what was electronics at that time. So for you, when I talk about revolution, it doesn't mean anything, because you are living in post-revolution period. Because 90s was a revolution. You are, I don't know, nowadays they call generation Z or A or alpha, beta, I don't know what they call you. Okay, so you are in that generation. So, but uh, if we look at the topic that we have chosen today, can you turn on the presentation, please? Yeah. See, can we develop world-class science and technology in India? Number one. And this also has two parts. Yeah. Stay on that. Can we meaning Indians, do we have the capacity to develop at all? That's also a question mark. Okay, we need to answer that question. Then, can we do world-class work? Second question. Third, can we do it in India? Because we know a lot of Indians who have gone abroad and done top-class work. And fourth, for India, because India has its own problems. India's problems are different from America's problems or Europe's problems or Japan's problems. So can we do world-class work to address the problems in India? And lastly, can we do work in India which is useful for the entire world? So as you can see, there are a number of questions which I am trying to give address here. So obviously, it is not going to satisfy anybody. Anybody who is seriously interested in answer to any one of these 5-6 questions which are in the title are not going to be happy, because each one might require a 1 hour, 1.5 hours lecture and more and especially discussion and the interaction and so on. So I am just going to give you a jhalak of what is involved here. Second, disclaimer. I was very ambitious, and because you are all children, I didn't want to like force you into engineering and technology, so I also added science. But as I prepared the slides, in fact, I completed it today morning only, final touch, I realized that I was too ambitious. So I'm going to ask your forgiveness. I'm not going to talk in much about basic sciences here. And each one of them will require a separate lecture. World-class physics, world-class chemistry, world-class biology, world-class other applied sciences in India. What has been done, what is being done, and what can be done. Okay. So again, I'm going to modify this and stick myself more or less to technology. And we are all consumers of technology, right? All of us have mobile phones, some of us have laptops. If we don't have at home, at least in schools or colleges, we have seen laptops and computers. But now, we have online lectures, especially after COVID, and we are having video calls in WhatsApp, right? And so on. So there is a whole new way of communicating, learning, even accessing information. Now, when I started working in journalism, Google just was born. And in fact, the person who inspired Google and the guru of Google was an Indian, a friend of mine. I'll talk about him later. Um so at that time for us, Google able to search the almost the entire internet and within few milliseconds give us some answers or some pointers to which websites we should go itself was a big revolution, because it looked to us that the world has become our library. Library is in our computer. We don't have to run from Bombay University to UDCT to IIT to TIFR to BRC look for one particular paper or a book. It looked like suddenly the world has become our library, and and we can access it through our laptop or a desktop computer. Those days laptops were less, desktops were more. But now you have ChatGPT, which not only gives you where to go, but it gives you a summary of a topic of whatever exists based on whatever it has digested from the internet, right? So you have very many new tools, right? Now in this world, you are now going to go forward and think about what are the problems and what can be our role, and what icons are there who can inspire us into do so. Because for each of these 6 questions, I can give negative answers also. No, we are not capable of doing this thing. No, it cannot be done in India. No, it cannot be done world class. No, it cannot be done for India. India's problems are too complex. Or sitting in India, I cannot do technology for world. All these are also correct, because there are any number of people and books and papers written on those topics, how it cannot be done. And they are with very solid data and answers also and examples. So as they say in India or in generally in life, for every question there is a counter question. For every example there is a counter example. So nothing, by giving examples you do not prove anything. By giving counter examples you do not disprove anything. But examples can inspire you to be positive and don't worry about problems. I still I can do it. If so and so can do it, I can also do it. For us it was a big thing that when I went to United States in the 70s, mid 70s, I met people who were like, for us sitting here in IITs also, they were like gods for us. They were the gods of physics, theoretical physics. Feynman, Schwinger, Weinberg, Sidney Coleman, Thuft, all these people went on to win Nobel Prizes later. Not in 73, 74 when we went abroad. But I met them all in conferences and then I said, these are human beings. हमारे जैसे ही हैं, हमारे जैसे ही बात करते हैं, मिस्टेक्स भी करते हैं. So that gave us a lot of confidence. People whom we had only seen in textbooks, people who had heard about their breakthrough technology and science, were also human beings, just like us. So that gave us some confidence. Now, of course, you have many, many more examples. Those days, Indians hardly in the entire Boston area, there is not a single Indian store. Okay, and Boston is, you can say, the center at that time, center of academia in the United States, because Harvard is there, MIT is there, and 10 other top universities are there, right in the few square kilometers. So it was considered as a hub of academia since the Second World War, actually. So now you can sit here and access all those things. You can listen to MIT lectures, you can listen to IIT Madras lectures, you can listen to those who are not here, you can listen to my lecture, for whatever it is worth, right? And so many other things. So whole issue of distance, we called it at that time. In my book, I talked about it, Sand to Silicon. But that book itself is 20 years old. That time we are talking about death of distance. This is going to happen. But that is no surprise to you. You are already, experiencing it. Death of distance means there is no distance anymore. You are not distant from your workplace. You can work from home, work from anywhere, right? There is no distance from the university. You can sit anywhere and listen to those lectures. Or later they will be on YouTube or on NPTEL or MOOC. MIT and many other universities have these online lectures also, courses also, and so on. So suddenly there is access to information has exploded. Information content has also exploded. So it looks overwhelming. In our days itself, physics was overwhelming to us. Arey baapre, already quantum revolution has happened in 1925 and we are studying it in 1970s. 50 साल में इतना all major things have been done. अभी करने को क्या है? क्या बचा क्या है? That type of thing. Now I can understand your anxiety because you are even studying it 50 years later than me. So even more explosion has happened in knowledge, in information, in data, even in some kind of trends. Though basic concepts and basic theories have not changed much. Even in computer science and communication, they have not changed much. Basic ideas remain the same. What happens is every 5 years, fashion changes and some new name is given to an old concept. I'll guarantee you this. I can give many other examples for this. That it is fashionable to call something new every 5 years. And so you think something new is happening. Okay, today you talk data science, data analytics, this, that. 15 years ago, 20 years ago, people used to call it data warehousing and data mining and so on. Okay, today we talk about cloud. Earlier we used to talk about grid computing. Before that we used to talk about shared resources. 1960 May we were talking about shared resources. In fact, the first experiments with large scale computers in MIT and later even in TIFR was that can we sit in Powai, which is like 40-50 kilometers away from TIFR in Colaba, and access the TIFR computer or not? Okay. Can we have a terminal in IIT Powai and access the TI for computer, or do I have to travel all the way from Powai to Kanjur Marg or Vikhroli station, sit in the come to VT, from VT go to Kolaba and then go and sit in TIFR? And in fact, one boy from IIT Bombay called Yogendra Lal actually was trying, they said that, Arey, I am too lazy, can I sit here and do it? So he asked his professor, there was a Professor Isaac who used to head the computer science department in IIT Bombay. He asked him, sir, can I do this as my BTech project? He said, do it. So he tried to do something. If not, Powai, can I sit in even VJTI and try to connect it, and so on and so forth. And like most student projects, it also failed. But then after his BTech, he went to Stanford to do his PhD, and he and his PhD advisor called Winton Cerf and one more student came up with a technology which is today the basis of entire internet. It is called TCP/IP, Transfer Control Protocol, Internet Protocol. Entire internet is based on that. And that was formulated by this Yogen Dalal, Carl Sunshine, another graduate PhD student, and the Professor Winton Cerf. So lots of times, you know, the things come out of necessity or some convenience, which later become big technologies which can, you know, change the way we live, the way we access information, way we do commerce, the way we do our relationship with the government, and so on and so forth. Okay. So what I am going to, so all these things, that's why one needs to look at basic concepts, because basic concepts haven't really changed. When you talk about, let's say, data compression or cryptography, coding, what does that mean? Codes have been used from, you know, thousands of years. People who wanted to hide what they are saying, so they'll use some code. In fact, in Maharashtra and some parts of Karnataka in the early days, they used to have some lipi called Modi, which nobody else could figure it out what it was. Only people who knew Modi can understand. Even now, if you have some very old document, you have to go and catch a Modi specialist to understand what is in that document. Okay, and that is some sort of a code. People who could read Marathi could not read Modi. People who could read Persian or Urdu could not read Modi. But many accounts and documents were written in Modi, and so on. So encryption is nothing new about it. Hiding, not open, you are trying to keep something secret, there is nothing new about it. Today we say quantum computing will break the encryption. Maybe, you know, if you develop a quantum computer and all that. But I'm sure there will come a new technology which will defeat the quantum computing also, or make it even more difficult, and so on. So this is a race. Basic concepts remain the same. When you say data compression means what? As much data you want to put in as little as possible, right? Earlier, one concert, Lata Mangeshkar concert, or a Pandit Jasraj concert, or anything. Some of them I heard here in the hall in Nehru Center itself. Those kinds of concerts, we needed a 800 MB CD or a DVD to get a exact replication of what they were saying. Today you carry it in your thumb drive, right? Of course, thumb drives have also become many GB now, but even in our days, when we had 4 MB, 8 MB thumb drives, 16 MB thumb drives, that itself was a big revolution. Okay, so even in that we could keep concert quality music. How? Because people developed, and in fact an Indian did that in the United States, called N. Jayant, that they developed a technology called MP3. And MP3 cut the entire data compression by 10 times. So what could be 1 GB could now be less than 100 MB. Okay, so you could even send it through telephone wire, or later wireless, or carry it in your pocket. Okay, so data compression. So what does that mean? In less space, you are putting so much more information. But what does that mean? If you are packing your suitcase to go somewhere, either your parent or your grandparent will say, अरे बेटा थोड़ा इसको अच्छी तरह आयरनिंग गिरनिंग करके रखो, ज़्यादा चीज तुम रख सकते हो. If you throw crumpled clothes inside your suitcase, then very soon it looks full. Right? Why? There is still lots of air spaces in the crumpled cloth. But if you neatly iron and keep, many more shirts and pants and dresses you can put in the same space. That is basically the idea of data compression. You do not leave any blank spaces anywhere. Try to cram as much as possible by neatly arranging it and neatly accessing it later. and so on. So basic concepts in engineering and science, many of them are very ancient and very simple. They get fancier and fancier names later. Okay. So now I'm just going to throw a few examples and faces at you. First thing is, um, okay, did we have any technology before? In ancient India, yes, we had. I'm not going to talk about it. These are just some examples: zinc metallurgy, steel metallurgy, casting, forging, etc., cotton, silk, textiles, even animal husbandry. Okay, that a bull can be converted into an ox. Without that, you can't have agriculture. That requires tremendous understanding of bovine reproductive biology. Okay, that you can convert a bull into an ox. So very beginning of agriculture started with understanding bovine reproductive biology. Don't forget that. Same thing with agriculture. Agriculture meant plant breeding. Tens of thousands of years of plant breeding has led to today's rice and wheat and all these things. These are all grasses, grass seeds, wild grass seeds. So everything in which was done thousands of years ago is also technology. Without technology, they were not occurring in jungle. In jungle, what existed was different, and even agriculture meant technology. If you are just like collecting something from the jungle, that was different. That you are just harnessing nature. But the moment you say, I am going to sow this seed and that will come up from it, that is technology. Okay, and so on. So, urban planning, we have seen all these great planning, even from the Harappa days and all that, how they used to plan their cities, right? Irrigation, hydrology, and so on. These were all very common. That's why you see that even in the Himalayas, for example, if you go to Almora, Almora has hundreds of fountains, natural springs. Okay, and how they were found? They were not existing before. A king of Chand dynasty, whose capital was somewhere else, wanted to move up the hill towards Almora. So he sent his engineers who did hydrological work, found these springs, created those what are called naulis, and then shifted his capital. Because without water, you can't have capital there. You can't move your residence and offices there, right? And similarly, earthquake proofing. Earthquakes are not new. Himalayas are the youngest mountains on earth, right? So that's why they are geologically very active. So there have been large number of earthquakes. But still there are 200-year-old, 300-year-old houses in Himalayas. If you go to Gadwal, Kumaon and parts of Himachal, you'll still see these old 3-story, 4-story houses which are 200, 300 years old. But we build concrete houses and with this thing they crack and fall down. And we think RCC is a great technology. And these are 200-year-old houses, how they are remaining. So they knew how to build houses with which could withstand earthquake. And not just houses. It is nearly 400 years since the Taj Mahal was built. It is more than 700 years since the Qutub Minar was built. Are there any cracks due to earthquakes? Has it fallen down because of earthquakes? That means they knew foundation engineering, they knew earthquake engineering. Okay? So you can, because we have not found many documents explaining these things, we have to go by artifacts. We cannot go by stories. We cannot say, "Is story mein aisa likha hua tha, so that was science." We need material proof. We need documentation. Okay. But when we do not have documentation, we have to start working backwards. Oh, ये तलवार मिला. ये तलवार का स्टील क्या है? ये कैसे आज तक ये जंग नहीं पकड़ा है? Why iron pillar of of Delhi has not rusted? So now we use electron microscopes and a whole field called archaeometallurgy has come into being to understand how was this steel produced and why this steel has not rusted. And what could have been the technology which produced this kind of steel, and so on. So we have to do detective work, okay, because we do not have evidence clearly for many of these ancient things. But what we have is artifacts. From that artifacts, we can say today we used to think 1000 BC mein iron technology was developed and even some kind of steel technology was developed in India. But today archaeological finds in Tamil Nadu are saying 3000 BC. That means 5000 years ago they have found some iron age civilizations, some artifacts. So our learning of the past keeps increasing. Nothing is fixed. Nothing in that narrative and all that. That is just like completely changing. You can just say based on today's data, we can think like this. That's all. Okay. So, but based on that artifacts, we can think like what could have been the technology in those days. We have found very ancient 1000-year-old dams. which prevented both silting as well as flooding. So what was the dam technology? How did they design their dams? Right? How did they design even temple? Forget complicated temples. You are all from Mumbai. You can go to Mahakali caves. You can go to Karla caves, Bhaje caves. You can go to Nasik caves, Mahad caves. Many of these Buddhist cave temples were built in from 1st century BC to Satvayana period, 4th century, 5th century AD. So in that time, 1st century BC, how were they cutting that rock? We all go there and study two things. What? Who built it? When it was built? And ये मूर्ति कितना सुंदर है, ये किसका है? ये जैन है, बुद्धिस्ट है, या विष्णु का है, या शिवा का है? This all we study. We don't look at what technology was used to cut that rock. What kind of metallurgical tools they had to cut that rock, hard rock? How did they polish the thing? How did they chisel the thing? Right? And so on. So there are many issues of technology and science to produce one artifact. Everybody loves these Nataraja bronzes, okay, from Tanjavur. They are called Chola bronzes, right? And these Nataraja and all kinds of things. They are cast to such perfection that now archaeometallurgists have studied what was the casting technology used to produce these bronzes. And that is very superior technology. Nobody else had it at that time. They developed it. And of course, they created these kinds of idols with that. So you can look at similarly rocketry. We think that rocketry developed in, we say Cargrave. Cargrave was a British engineer who developed rocketry. He is called the father of rocketry. Later Germans took it and made missiles. And some of those German scientists went to America, or rather taken as prisoners there after the Second World War, like Werner von Braun, and he was made charge of NASA, and then he developed the NASA. So this is the way rocketry and missile technology went to America. But where did Cargill get this technology, do you know? He took the rocket samples from Tipu Sultan. After killing Tipu Sultan, they found that Tipu Sultan had developed these modern rockets. He was using it as missiles against the British. So hundreds of those samples were taken to England by the British. And Cargill developed his technology based on initially Tipu's designs, and so on. So there was technology in the ancient India also. Now what we have to see is, then what happened? So actually historians have now found that till about 1600 AD, worldwide, in mathematics, astronomy, science and technology, India and China were far ahead of any other country. And in fact, European scientists and philosophers were writing in admiration of India and China. Oh, dekho, wo kya kar rahe hain? They are producing this, they are producing that, we don't have anything here. In fact, even Bacon wrote extensively. He said, we are stuck, I am stuck. And we call Bacon as a father of modern science in Europe. And he has written extensively saying, look at India and China, what they are doing. Okay, so till 16th century, if you see, more or less, India and China were ahead of the rest of the world. But what we see is a big transition after 16th century. Then we start seeing modern science, modern physics, modern chemistry, modern geology, modern biology, and so on developing, where we all lost out. Asians all lost out. We did not go forward. They went forward, and modern. That's why today modern science is primarily European in origin. Okay. So the 18th century, 19th century industrial revolution, including up to computers and all the electronics and all that, basically came out of Europe. Only with the Second World War, the center of gravity shifted to America. And after the Second World War, you see everything coming from America. Forget India, not even from Europe. We talk about brain drain from India. You talk to British, they are all crying. They say we do science in Cambridge and Oxford, but all technology is developed in Silicon Valley. Germans say that, Swedes say that, French say that, everybody says that all technology development is happening in America, even though science is being done in Europe and some other countries also. So it's not just our problem. So it's a problem worth studying, why it is happening like that, and what can we do in our country to create a system where we can also develop cutting edge technology. We can also develop at least also ran technology. Okay? कि ओलंपिक्स में हमने गोल्ड मेडल नहीं जीता, but final 6 में थे, right? Finals में थे. That is good enough, because even that, you just being a national champion is not good enough to be in the final heat of the 100-meter race or 400-meter race. You have to be top 6 of the world. You may not be any medal winner, but still you are in the final heat, means you are a top athlete. Okay. So can we do even that? Because if even that is good enough for our economy, our people, and other countries like us, even that is a important achievement. Okay. So number of these things, I'll just give you some examples. So these were the things which tell us that in the past we did have technology. But what about modern technology? If you look at what about modern technology, every damn thing that I'm going to list is outside of India. Telephone, US. Telegraph, UK and US. Tape recorder, Germany. CD, Japan and Holland. DVD, Japan. Xerox, US. Thumb drive, US. Though thumb drive was invented by an Indian in US. Okay. You went from here, from Bits Pilani, Sanjay Mehrotra. Cinema, France. Airplane, US. Mobile phone, US. Computer, US. Software services, India, which is still true. Internet, US. WhatsApp, US. Car, US and Germany. Bus, Europe. Railway, UK. High-speed bullet train, Japan. Metro, UK, USSR and France. Jet airplane, UK. Jet engine. TV, UK. Submarines, Germany. Atom bomb, US and Russia. USSR, Soviet Union. Cement, UK. RCC concrete, France. Earthquake-proof building, modern day, Japan. Tar road, UK. Okay, that you can use dumber for making better roads. Aluminum, Europe. Germany mostly, but even other countries, Europe. Tapped water supply. Okay. Nal mein jal aana chahiye. We are doing that Jal Shakti mission and all that, right? Where was it invented? Europe. Polyester, nylon, all these man-made fibers, UK and US. Plastic, US and Germany. Air conditioning, US. Fridge, US. Electric bulb, US. Printing press, Germany. Motors, motors means electric motors, UK. Pump sets, Europe. Water pump sets. Ballistic missiles, Germany, which they started in the Second World War. First, allopathy medicines, again, Europe and US. Antibiotics, Europe. Telescope, Italy. Sonography, US. CT scan, US. MRI scan, US. Urea fertilizer, Germany. Tractors, US. LED lighting, Japan. What we are using here. These are not old LEDs. These are called blue LEDs made of gallium nitride. They got a Nobel Prize later for that. They were developed in Japan primarily. Pesticides, again, Europe. Okay. So that is the state of industrial technology. If you look at 18th century, 19th century technology, which we are all consuming or trying to consume, because even, huge number, almost a billion Indians do not have access to many of these things. Maybe 300-400 million have access to many of these things. So when you talk about middle class and all that, that is the 300-400 million, which still looks big to them because the entire population of the United States is 350 million. So for them, Indian market looks big. But for us, we know what has happened to the other 1 billion. They don't have access to tap water, tar road, all these other things which we take it for granted. Our complaint is, khadde bahut hai, right? They are not good enough. We don't have expressways, right? We do not have 24-hour water supply, right? Our rivers are getting polluted, or the pollution jada ho gaya. Should we run on lithium? We should have electric cars, right? But we don't care where the lithium is coming from, right? Or how that electricity is coming to charge it. Is it being made by coal or what? And if not by coal, from what? Because solar doesn't give you any electricity in the night. So we should look at anything holistically, not just look at some small part and say this is advanced, this is good, that's not good. Everything has a history and its place. So anyway, now we come to the modern digital technology. So all this we missed. This whole bus we have missed. We are just trying to develop enough to provide some of these conveniences to our 1.5 billion people. And if you are able to do that, it's a big achievement. And there are 6 billion people in the world like that. And a great management guru called C.K. Prahlad, he called it bottom of the pyramid. There is a pyramidal structure in the quality of life in the world. There are people at the top of the pyramid, which is very few. And there is a middle, and then there is a bottom of the pyramid. The pyramid is like this, no? The bottom of the pyramid, huge number are there. They are the poor, lower middle class, in quality of life terms. Even you ignore dollars and rupees and all that, just quality of life terms. So that bottom of the pyramid itself is 6 billion people. That is 75-80% of the Earth's population. So if you develop anything for the bottom of the pyramid, it will not only be useful to India, but for the rest of the 6 billion people also. Okay, so remember that. So that is what today we call as also for India. When we say technology for India, it is also for the other 6 billion people on earth who are in similar situation and who will also benefit from what we are developing for these people. The 6 billion people or 1 billion people do not require an iPhone. They cannot afford to give 2 lakh rupees to get an iPhone and stand in the queue in BKC in the Apple store. Right? In fact, they are so poor that these 2 lakh people iPhones might get stolen on the road by others. Because 2 lakh is not even their annual income. Even if they are able to go and sell it in Chor Bazaar for 50,000, it's a big thing, no? So those days can come if you do not take care of inequality, if you do not take care of poverty elevation. So we have to take care of that. How are we going to raise the quality of life of 1 billion people? Not just this 100 million or 10 million. The Europeans and Americans and everybody else is looking at those 100 million, 200 million. In fact, I remember not now, in 1978, French president was visiting America. I think it was Mitterrand or Giscard d'Estaing or something, one of the first French presidents. And at that time, there was a full-page ad in Times of India by somebody, Indo-French Council or something, which said, there is a France in India. That means for every citizen in France, there is another citizen in India who has the same standard of living. They did a mapping, income mapping, quality of life mapping, and they found at least one France in India. So that pleases the French. That may not please us. That why only one France is there in India? Because France is less population than Maharashtra. Okay. So Maharashtra is bigger than Germany, bigger than France, bigger than UK, and all that, just in population. Okay. Those countries are the size of Goa and Uttarakhand or Himachal or Jammu Kashmir, something like that, in terms of population. So here, I used to say, a world-class project, when you talk about IT projects, changing the life of people, I used to say, if you can touch the life of people in one district of India, what is the average population of a district of India? Do you know? There are 600 districts in India. You divide 1.5 billion by 600 districts, it comes to two and a quarter or 2.5 million people. That is more or less a population of New Zealand, Ireland, and many other countries. So if you can change the life of people in one district of India, it is like a world-class project. Don't forget that. Don't think this is small. What anything can be done to improve life in India is small. Don't think that. Okay. So now if you are looking at whether Indian brain can do it or not, or have we lost it? Because Europeans said that also. अरे Indians ना वो बहुत mystical है, they are thinking about the other world. पता नहीं किस धर्म कौन सा भी धर्म के हो, they are thinking about Swarg and Nark and all that. They are not interested in this world. Europeans wrote like that. And that is the reason India is poor and they don't care. They are not interested in material wealth and all. Which is anyway wrong, because India did not become prosperous by looking at the other world. India became prosperous by using technology, by what is called Abhyudaya, by material progress. And that is the reason Europeans came here. If India was not prosperous, Europeans would not have come here. Why should they cross all these thousands of miles of sea and half of them were dying on the way? Why should they come and reach here? Because India was prosperous. And why India became prosperous? Not by thinking about the other world, but thinking about improving this world. Some people may be thinking about the other world, that's okay, but not the ordinary people, right? They are always interested in improving world for themselves, their children, their grandchildren, and so on, right? So, to disprove that, I'm just going to throw a few names and here also I can give you 40, 50 names and stories. I don't have the time. I'll just show a few photographs, maybe 8, 10 people who did outstanding work, which created the foundation for today's digital technology. This is one of them. Narinder Singh Kapani, boy from Dehradun, he invented fiber optics. He's one of the few people in 20th century, 21st century who can be called father of a technology or a mother of a technology, because you cannot use that word anymore. You could say at one time, Graham Bell created telephone, Alva Edison created the electric bulb and all that. or so and so created the telegraph, or somebody created the radio. You could have said that. Today it's not possible. Any technology requires thousands of technologies from multiple countries to do prototypes, to do proof of concept, to come out with a product, come out with a better product, and finally reach the market. And within seconds, an idea can get picked up, and a new startup can come in some country, and even venture capital can go into it and start pursuing that idea. So no longer you can say this is Indian technology, that is American technology, this is Chinese technology. Even nationality of a technology is a question mark. It is just got to do with who has got the patent for it. And today we are filing thousands of patents, huge number of patents. Biggest jump in patent filing is happening in India, in the whole world. Not the number of patents, but the rate of growth of patents. Number of patents, many smaller countries are ahead of us, even today. Okay, but the rate at which the patent filing is going up, India has got the fastest rise. But we have to see, they are being filed in India by whom? Are they being filed by Indians working in Indian companies, Indian IITs, Indian colleges, Indian universities? Or are they being done by Indians working in IBM and Intel and Motorola and all that in India? Because IBM has more engineers in India than in United States. Many American companies and Japanese and European companies have in India researchers in India working for them, their technology. India has the highest number of chip designers, cutting edge chip designers. But none of them are, hardly anybody is working for Indian companies, they are working for multinationals, but in India. These are called Global Capability Centers, GCCs. And suddenly from 150, 15 years ago, they have become today 2000. 2000, that means more than 2000 world leading companies are doing their R&D in India. Not just IT, pharmaceuticals, aerospace, rocketry, artificial intelligence, you name it, every single technology works. We talk about General Electric not giving us engine for Tejas because we don't have a engine for Tejas, our Air Force, right? But General Electric's biggest R&D center is in Bengaluru, and Indians are sitting there working for General Electric, and 40% of the General Electric's aircraft engine is being actually designed in Bangalore. But the patents and intellectual property will be owned by General Electric, not by any Indian or Indian company. Even if he's an Indian, he's an employee of General Electric, and so on. So it's all very complicated now. You cannot just say some technology is this country, that country. It's a big network. But still, we would like to see whether Indians are capable of it or not. So this is one great example. In 1951, he was a BSc in physics from Dehradun. He got an opportunity to go to London, to Imperial College. He did his diploma there, then PhD. And in PhD, he took up this problem that can I send light through a curved path? Everybody learns in high school, right? Light travels in a straight line. Geometrical optics, right? Laws of reflection, refraction, all that. But he said, can I make the light go through a curve? How to do it? So I'll take a glass fiber, since glass is transparent for light, and that fiber will be curved, and can the light go through that? And his PhD guide had no idea about it, but he said, okay, try karo. So Kapani was thinking about it, sitting here in Dehradun. He had no solution. There he said, okay, let me draw a fiber. Instead of, earlier he was thinking of prisms and all that. So he created a fiber, but then fibers were leaking light everywhere, right? You know, you have seen these lights for decoration you keep. You put a light below and you put fibers and all the fiber looks lit up. But that is not what is useful, no? Where all the light is coming out of the walls. It's not passing through it. So how do you take care of that? Light should not leak from the walls of the fiber, it should reach the end. So he developed that and published a paper in 1954 in Nature magazine, which is one of the top science magazines. And that was his PhD thesis. And later he gave the name fiber optics for that. So we can safely call him father of fiber optics. Okay. And unfortunately, in 2009, when the Nobel Prize was given to fiber optic work, he didn't get it. He didn't even share it. Another Chinese engineer was given, Chan, because he used fiber optics to use the laser to send a signal and use it for communication. Today we talk about laser communication, submarine cables, internet and all that. That is all fiber. We are talking about fiber being laid by BSNL and Reliance and this and that. क्यों खड्डा है हमारा रोड में, वो फाइबर डाल रहे हैं, ऑप्टिकल फाइबर डाल, राइट? So that optical fiber, मतलब वो टेक्नोलॉजी का ओरिजिनल डेवलपर was नरेंद्र सिंह कपानी. At that time there was no idea of communication, so he used it for medical purposes. So I think, and I wrote an article also about it in the international press, that he should have been at least given a medical Nobel Prize. Because endoscopy, laparoscopy, colonoscopy, every scopy in medical medicine uses this technology. They are using fiber optics to see what is inside your body, and then accordingly do the surgery or whatever it is that you want to do, just investigation, right? And for many of these things, people have been given Nobel Prizes, by the way. People who have done CT scan got Nobel Prize, people who have done MRI scan got Nobel Prize. So why not scopy? Anyway, so that is the way it is. There are at least 5-6 Indians like that whose work somebody else used and they got Nobel Prize, but the people who had developed the original science did not get Nobel Prize. He is one of them, you can say. So Narendra Singh Kapani is one. Nikhil Jain, PhD from Indian Institute of Science. He went to in US in Bell Labs. His team developed MP3. Arun Netrawali, in fact, he studied in a municipal school in Dadar. His father was not well off. He was studying in a municipal school, went to IIT Bombay, topped IIT Bombay, got the President's Gold Medal, went to US, and there in Bell Labs again, his team developed today what we call HDTV. High definition TV was, and many other things in video compression and image compression was developed by Arun Netrawali's team. Sanjay Mehrotra, I already told you, he developed the thumb drive. He is also a boy from India, from BITS Pilani. He did first or second year here and then went to America. Because his brother was in America, he sponsored him. So he's establishing a factory in Goa, in Dholera in Gujarat. One of the first chip projects which were announced was by his company, Micron. He's the chairman of Micron now. Arogya Paul Raj, he's an Indian Navy officer, but his patents, which he later developed in Stanford University after going out of Indian Navy, are the foundations for 4G and 5G. Foundational patents of 4G and 5G are held by Paul Raj. Balamanian, he unfortunately he lost one eye in childhood. Now he is a mechanical engineer, but he developed his work in optics, and he developed the technology to convert film into digital file and digital file into film. In those days, everything, Hollywood, Bollywood, everything was in film. So something in a computer can be converted into film, and something in the film can be converted into computer. He was thinking about using it for medical electronics. Okay, that means suppose X-ray is there, you take an X-ray. I want to consult somebody. He is sitting in Delhi or somewhere. I am in a village. What should I do? Can I convert it into a digital file, send it to him? He can see it on screen and tell me the analysis. Right? Today we do it routinely. But that time, this is 1973-74, by the way. That time there was no computer and there was hardly any telecom. There was copper wire telecom, even in America. So there he developed that original concepts and patents, which were later picked up by Hollywood. So he is the first Indian who was given an Oscar. In 1999, he is given an Oscar because entire Hollywood special effects technology is based on his patents. Because there are two biggest companies of creating special effects in the world, Pixar and Industrial Light and Magic. Both of them took his patents and developed the work. So he was given a special Oscar in 1999, Balamanian. Okay. Rajiv Motwani, friend of mine from IIT Kanpur, he, brilliant computer scientist, he mentored, like there were two of his students in Stanford. He was teaching in Stanford. They came to his for assistance, for advice. He worked with them, helped them, and three of them together wrote the paper which created Google. So he is the mentor and founder, you can say founder of Google. And because he actually gave them that idea and wrote the original paper, though he continued to teach, he didn't go out. Those two students, Sergey Brin and Larry Page, gave him $1 billion as Guru Dakshina that time, 20 years ago. Today, I don't know that $1 billion has become how many billion dollars. Okay, that time Google was just a startup. But unfortunately, he died in an accident in 2009, in a very tragic, in his own swimming pool. died in mysterious circumstances. Okay. So those are just, I could have given 40 more examples like this of fundamental work, but this was just a jhalak to say that Indians can do it, can do cutting edge work and have done it. I'm not talking hypothesis because I don't believe, basically, my background is in finding truth from facts. If you collect 100 facts, then you see a pattern. From that pattern, you can make a generalization. Don't start with a generalization. Okay. And that helps me. That helped me in journalism, because in journalism, one or two people sit and write editorials and they tell the prime minister what he should do or he should not do, or what Trump should do, should not do. Rest of the people are on the street trying to find what is happening. Reporters, they are called. That is the core of journalism. Report what is happening. बाद में उसके बारे में theory लिखो. Okay. So if I gave you just some examples, from that you come to your own conclusions. What is possible, what is not possible, what could have helped them, what could have hindered them, etc., and what you can do. So now I'll just give again a few examples of advanced technology developed in India, because all these fellows studied in India but did all that in America. Can we do it in India also? Is a question, right? So again, I don't want to say yes or no. I want to give you examples. Here is Jagdish Chandra Bose. Everybody thinks Jagdish Chandra Bose means what? Oh, he said plants can cry, plants can feel, right? This is what we see, neurobotany, etc., right? But people don't know Jagdish Chandra Bose was a great electrical engineer, great physicist. So he first developed the technology, what today we call microwave engineering and semiconductors. And based on his work and his inventions, Marconi made the radio, and Marconi got the Nobel Prize. Jagdish Chandra Bose didn't get it. And he publicly showed it in Calcutta. Then he went to London and publicly showed it. Then in London, one American gentleman came to him and said, Mr. Bose, you should patent this. Bose said, I don't know what is patent and what is the use. Science cannot be patented. He said, no. These are important things. Whatever you have produced, he had produced some special equipment for both sending microwaves and receiving microwaves. Okay. So he said, you should patent this. So Jabardasti, because of his pressure, he filed a patent in 1901, and he was given a patent in 1904. I don't have time to show you, but I have the copy of that patent also. So that is the first ever patent in solid state devices and semiconductor industry. That was given to Jagdish Chandra Bose in 1904, when people didn't know what is semiconductor physics. Okay. So you can say sitting in Calcutta in colonial rule, in his whatever equipment he had, he came up with the technology. Okay. And he did not come out with radio product for the market, but he developed the basic technology. So we are talking about, can advanced technology be developed? I am not even talking about advanced product. That again is another problem. Technology itself, which is again different from science, as you know. Okay. So second example is Professor Narasimhan. He was a mathematician. He was asked by Baba to build a digital computer, because Baba established TIFR for two things. In 1944, he wrote a letter to J.R.D. Tata, and J.R.D. Tata forwarded it to Jawaharlal Nehru. He said that we should establish a world-class institution in India to do research in electronics and in nuclear physics. That time, atom bomb was a secret mission. Atom bomb had not yet been exploded, not even been tested. But Baba knew something like this is happening. So he wrote this letter saying in India we should start this work in 1944, 3 years before independence. And Tatas gave the money, Nehru agreed with it. In 1944, TIFR came into being in a building in Malwa, which was again belonged to a Tata family at one time. Much later they moved to Colaba, and then TIFR was established. Okay. So Baba told Narasimhan, let's build a digital computer. This was in 1951 or something. And in 2 years, 4 engineers, Narasimhan was not an engineer, he was a mathematician, but he had just come back from US and he had used a computer for some of his mathematical research. That's all. He was not an engineer building a computer. He had used computer for calculations. And he had 4 other people who had some background in electronics, but at the level of what was in Akashvani at that time. But they had never seen a computer. And here Baba was challenging them to build a digital computer. But they did. In 1954, they built the first digital computer of India. It was called TIFRAC, TIFR Advanced Computer. And it was as good as any computer in the world at that time. Now, unfortunately, they didn't have air conditioning because still the new building had not yet come up. It took them 2 more years to build that new building, in which with air conditioning they could test it. And by that time, others had moved ahead. So, but they showed in 54 that we can build a computer from first principles, from basics, from valves. That time there was no transistor at that time. Using valves, that we can do something which is also world class. But that created the first computer programmers and scientists in India. That computer. People used to be going to TIFR to just learn what is a computer and how to use it, how to program it. Later, of course, he was one of the pioneers in artificial intelligence, vision, and what is called pattern recognition and all that. P.P. Gupta, he was the MD of a public sector organization called CMC. Now, to his credit, he took up this challenge that can I computerize Indian Railways? Now, I remember in 72 when I come from a small town in Karnataka called Dharwad, and I got admission in IIT Kanpur, and I had to take 4 trains to reach Kanpur. Dharwad to Miraj, Miraj to Mumbai, Mumbai to Jhansi, Jhansi to Kanpur. And if I go and stand in Dharwad, in the railway station 10-15 days before, in the queue, it was a small station, so it was okay. It was not like VT or Churchgate. Here, people used to come in the night, towel bicha ke so jate the, so that early morning they might be closer to the window and get some reservation. And पूरा 4-6 घंटे खड़े होने के बाद वो बोलेगा खत्म हो गया, बोगी फुल, दूसरा गाड़ी के लिए दूसरा विंडो में जाओ. ऐसे चलता था. This was the fate of Indian Railways. And Indian Railway itself was made up of some 12-13 railways in the British days. So each one of those 12-13 divisions and segments had different rules. Okay, so how do you computerize all this? And there were 7,000 stations. He took up the challenge. He demonstrated it at his own expense in Secunderabad station because CMC was based in Hyderabad. He showed it in Secunderabad using CMC's computers and telecom equipment that we can computerize this. And then at that time, Rajiv Gandhi and the chairman Sam Pitroda and they were all able to convince the railway board. And railway board said, okay, we'll do it, but you'll have to convince the unions. Because unions and politicians were against computers. Why? Because we have too many people here. Computers will throw out people from jobs. Today we are talking about AI throwing out people from jobs. That time computers were registered in banks, insurance companies, and any place saying computer aa gaye to sabka naukri chala jayega. So CMC told railway board and told the unions, not a single person will be thrown out. We will retrain old booking clerks into how to use a computer for booking. And they implemented it, so unions agreed. So entire Indian Railways was converted, computerized, booking got computerized. Now, of course, you sit in your mobile and do the IRCTC app and book, right? For this, it took another 15-20 years to put it on the web, then put it into an app, in a mobile phone, all that took much more. But this they were able to achieve in from 85 to 1991, they computerized entire Indian Railways. Now, it is not a small job. Many stations did not have no telecom. How do you connect computers? How do you make a network if there is no telecom? Many places you don't even have electricity. So how do you run these kinds of modern systems? So everything had to be robust, should be able to work in worse circumstances, in dusty, hot atmospheres, or pouring rain, or cold temperatures, whatever it is. So anything you do all India is like you can do anywhere. You can work in Siberia also, you can work in Sahara also, if you can do it in India. Because Thar mein या Rajasthan में 50 degree temperature होता है, right? And if you go to Ladakh and you want to have a lay station for something, there you go to -15, -20 degrees. Siachen तो -50 में जाता है. So doing anything in India means everything, all climates, all weather, everything, it has to be robust system. So they did that. And till 2010, 2011, that was the biggest digital project in the world, Indian Railway computerization. And it touched hundreds of millions of people, saved time, okay, increase the productivity, because I told you, you have to go and stand for a whole day just to get one ticket, and you're not sure whether you'll get that also or not, one berth or not. Okay, that was the situation. So that was, it got many awards and all that. Internationally, it got recognized. But most importantly, it changed the mind of unions, politicians, and ordinary people in India about computers. That computers can help us. Computers are not here just to take away our jobs. Okay, so turning point in India for digital revolution was the railway computerization. And P.P. Gupta did that, and his organization, of course. F.C. Kohli, he is a creator of, you can say, what today we call IT services, software engineering. In brief, what it means is, in our days, programming was an individual's activity. You sit in front of your computer, you learn the language, you use your logic and build a program. Now, another fellow, he might use a different logic and produce a different program to solve the same problem. So it was like a activity of an artisan, a kumbar. If he's a master craftsman, he'll produce a beautiful vase. If he's not such a good craftsman, he'll produce a chalta hai, 19-20 ka, pot. Somebody else will do much more artistic work. That is called artisan work. That is not called industry. Industry means you should be able to produce million pieces of the same quality and same design. That is called industry. Not I created one and next fellow doesn't know how to create this. He will do it in his own way. Aisa nahi chalega. So FC Kohli and then TCS, they developed the whole methodology on how to do software programming with 1,000 people sitting on the same project. How to break the project into 1,000 pieces. 1,000 people are working simultaneously on it, but each of them are using the same standards and same language and same method of programming, so that each piece they are making fits into the other. It is like a jigsaw puzzle or a Lego. Even if 1 micron difference is there, Lego will not fit. It has to fit perfectly, right? Otherwise, jigsaw puzzles won't fit. So software architecture, software programming is like that. And so Indian IT industry, starting with TCS, then later Wipro, Infosys, etc., 20 years later, they all together developed this whole software engineering. That's called engineering, not programming. Programming, any programmer who knows the language with a computer can sit and program it. That's not called engineering. Engineering means industry. That means standards, quality, and mass production, etc. So that is why India developed that, and even today, no other country has that capability. It is nothing to do with so-called cheap labor or nothing to do with Indians knowing English. This is all bakwas. Why Canadians and British and Americans don't know English? Or Bangladesh or Africa or somewhere else, the wages are even lower than India. Why they are not gone there? Why they come to India? Even the Chinese want to come to India. China, in fact, when I was in TCS, I went to China. They were welcoming all the Indian companies to come there and set up software companies. They were giving free offices. Come and set up here. Train our people. But they wanted to learn how to do software engineering. Okay. So IT services is a definitely world-class contribution to India and to the world by India, from India. Ramdore again followed it up, and in the Kohli and Ramdore's period, two things happened. Not only they were doing software services and doing the 21st century work for the world, but they said we should do 21st century work in India. That is how National Stock Exchange, computerization of stock exchanges happened. Computerization of banking happened. Computerization of Reserve Bank of India happened. Dematerialization of shares happened. So entire modernization of Indian financial sector, banking and financial services happened in India first time. Otherwise, we're going and doing it in New York or in London, but not in India. So today, and in fact, many countries in the 90s, from Russia, China, many other countries, delegations used to come to study our banks and our stock exchanges, because we had the most advanced systems at that time and the cheapest systems also. We had developed it with the least cost. Okay. So this is another thing. If you want to do anything in India, you can't be lavish. You'll have to produce world-class work with whatever you have. It is not jugaad. Jugaad is different. Jugaad is chalta hai, 19-20 chal jata hai, but you have overcome a problem. But you have to create a robust world-class solution with whatever you have. And that is what they were able to do. For example, NASDAQ is considered the most advanced stock exchange in the world. Most advanced stock exchange in the world. And then when the National Stock Exchange in India was built, they found that National Stock Exchange was as good or better than NASDAQ, but was using only 25% of the resources of NASDAQ. So this is what is important. This is called frugal engineering. Some Dr. Mashalkar called it Gandhian engineering and all that. Okay. How do you create solutions which are again frugal? You are not lavish. जिधर आप एक पेंटियम प्रोसेसर यूज कर सकते हो, आई विल से नो आई एम गोइंग टू यूज मैकबुक, 2 लाख रुपए का लैपटॉप यूज करूंगा, ये बोलेगा नहीं 30,000 का लैपटॉप में चलेगा काम, सेम इट विल गिव मी द सेम फंक्शन. Okay, and so on, number of things. So how do you construct your design, how do you architect your design, and how do you bring out your solution, how do you train your people, etc. For example, when the telecom modernization happened in India, the European companies mostly were asking to digitize Indian exchanges, switches, millions of dollars. So Indians decided we'll do it in India, and we developed the switch on our own, and a switch which could work without air conditioning in the dusty, hot regions of Rajasthan, or in the cold regions of Ladakh, or wet regions of Kerala. The same exchanges had to work. So because of that, today the switch that was produced in the 90s in India by an organization called CDOT, under the leadership of Mr. Sam Pitroda, okay, is the most widely used switch in the world even today. Nearly 78 countries are using CDOT switch. So this is also advanced technology, digital technology developed in India for India, but then it went to the world also. So these are just, by giving examples, I am telling you what are the unique things about the Indian technology, that what kind of problems it needs to solve, whether it is resource problem, environmental problems, and similarly, Nandan Nilekani, he headed the Aadhaar project. And today, that's why I said railway computerization was the most advanced digital project in the world till 2010. Why? Because in 2010, Aadhaar started. And today, Aadhaar is the biggest digital project in the world. And everybody is now trying to learn what India did, because it is called digital public infrastructure. It was not created by Google or a Microsoft or a TCS or some private company, created by the government, but it is created as an infrastructure. Just like a road is an infrastructure, this is a public infrastructure created at very low cost, and at the same time anybody can use it. So other countries, including America, are studying your UPI system and the Aadhaar system. And some countries are suspicious about it, especially Mr. Trump. He thinks that maybe UPI is going to use to bypass the dollar also. Direct agar exchange ho jata hai idhar se Singapore, that means you are bypassing the dollar also. वो कैसे होगा? Because he wants the dollar to control the world, right? So this is Nandan, this is Vitroda, Manindra Agarwal. This is just in theoretical computer science. Manindra Agarwal today is the director of IIT Kanpur. He was at that time just I think assistant or associate professor in 2001. He's a BTech, MTech, PhD from India in IIT Kanpur only. And he and his 2 BTech students did cutting edge work, solved a problem in computer science which was 300 years old. And I was in US at that time in Stanford University, and they were telling me, "Arey, IIT Kanpur se paper aaya hai, we are checking out whether it is correct or not." And it hit the headlines, it made the headlines in New York Times. And he had done the work with 2 of his students who were undergraduate students. And now today, of course, all of them have won all the Nobel prizes in the computer science. Nitin Saxena was one of his students. Neeraj Kayal was another of his students. So these 3 people had cracked a 300-year-old problem in mathematics and computer science, sitting in India. Okay. Now, of course, all over the world, they are famous. This is Professor Vidyasagar. Again, he was abroad, but Dr. Kalam said, well, if you want to work in India, come on. So he left all his job, and he had a good position. He had made a big name in electrical engineering and control theory. in Canada and US. So he came back to India. So Dr. Kalam asked him to establish Center for Artificial Intelligence and Robotics. When you heard artificial intelligence last year, no? This was in 86. In 86, Center for Artificial Intelligence and Robotics was established by DRDO in Bangalore by Dr. Kalam under Professor Vidyasagar's leadership. And they created the digital control system for Tejas, which nobody was ready to give. Nobody was ready to give you. They'll say you depend on us. They said we'll develop in India. So today Tejas has the most advanced Tejas light combat aircraft, fighter aircraft, has the most advanced digital control system developed in India by his team. So artificial intelligence is nothing new, okay? It's not some fashion which came last year with ChatGPT. The first conference on artificial intelligence took place 70 years ago, 1956, in Dartmouth College near Boston in New Hampshire. And they created an manifesto of artificial intelligence. Okay? That since then, since the birth of computer, people have been thinking brain also works like computer probably. So can we replicate what the brain does in a computer? So later we have found that brain is more complicated than a computer. Computer is simpler. So it's not that we can do whatever the brain does, but at least we can create some help, some tools for the brain, for the human beings. Not, we cannot compete with the brain. Human brain is, even a 1-year-old child is smarter than any supercomputer. Okay. I don't have time to discuss all that. So anyway, so these were examples. Then here, 3 people are there. 2 of them I wanted to talk about. I found them in the same photograph. Professor Dhawan, whose birthday is today, by the way, 26 September, says Suhas Naik. And there is Dr. Kalam also. Both of them are discussing with Mrs. Gandhi. This was, I think, in 1981-82 time. And Professor Dhawan actually created the basis for ISRO rockets and satellites. Vikram Sarabhai dreamt about it, but he passed away in 71. So when he passed away, Mr. Gandhi made Professor Dhawan, who was a director of IISc and a world-renowned aerospace scientist, made him the head. He said, I have to continue my research in Bangalore, so I'm not coming to Delhi. So she said, "Ye kaun hai? I'm giving him secretary position, find out who he is," and all that. Told the intelligence bureau and all that. They came out and said he's a very well-known professor, but he doesn't want to come out of Bangalore. He wants to continue his research in IISc. So she said, okay. So that is how ISRO Bangalore became its headquarters, because of Professor Dhawan. Otherwise, everything would have gone to Delhi and they would have been changing files. That's all, not doing any work. So Professor Dhawan created actually the basis for all the rockets and even the satellites and the rocket engines and all that. Kalam was his student. Kalam writes tremendously about what he learned. He is my guru, he says. Dhawan was my guru, he says. Okay. And so Dhawan created, you can say, ISRO rockets, and Kalam created the guided missiles when Mrs. Gandhi made him in charge of the guided missiles. Now, guided missiles are one of the most complicated things. They are not ballistic missiles. Ballistic means what? You throw a stone, that is a ballistic. You fire a cannonball, that is a ballistic. Projectile motion, right? You learn it in 8th standard, 9th standard, whatever, and you say how does a cannonball go, where it will parabolic path and all that, right? Range and all that, height and range and all that. So that is called ballistic. But guided missile or guided anything is not ballistic. Because ballistic means once you throw it, you have no control where, only you can calculate where it is going to fall. But guided means you can guide it further and change its trajectory. So that is the most complicated technology. So those were the technologies which were developed under Dr. Kalam's leadership. That is why everybody was looking at Agni, not Prithvi. Prithvi was a ballistic missile, Agni was a guided missile. And a lot of new technologies had to be developed for that. And they were all done. Nobody will give you any such technology for millions of dollars also. So there are some technologies which are very costly, like what was in the telecom. I was telling you, millions of dollars they were asking, but Petroda said that we'll develop it here with young scientists. That is one type. But these strategic technologies, certain sectors, Doesn't matter how much money you give, nobody will give you that technology. So there it is not a matter of whether you are the first or second. You have to do it yourself. So today, if you want a good Air Force, fighting Air Force, we need a jet engine for that, not just the frame and the control. So jet engine we still don't have. We have to depend on Americans or French for that. Even Chinese didn't have that. All this time they were using Russian thing, but now they have developed an advanced jet engine. They are trying it out. Once it succeeds, Chinese Air Force will become totally independent. It will not depend on Russia. So when we develop our own jet engine, we will also become independent, will not be dependent on any country. So, but nobody will give you that technology. Okay. This is last picture I am showing you of Professor Singhal, one of my friends from IIT Kanpur, and one of the brilliant people in language technology, using artificial intelligence for translating natural languages. And today he is the chairman, which is of the whole project called Bhashini, which is supposed to convert any Indian language into any Indian language. Speech, not just text. So in the parliament, if somebody is talking in Tamil or Hindi or Bengali, the other persons can listen to it in whichever language they want. So this is the ultimate dream of artificial intelligence anywhere. No Google, no Microsoft, no AI has developed it. Indians are doing it and they've gone far ahead in that under this Bhashini project. Okay. So then there are other examples. UPI, I mentioned Bhashini, ISRO services. Then I'm not mentioning anything about pharma and pesticides. Dr. Garda, DB Gupta, Dr. Reddy, Dr. Yusuf Hamid, Parvinder Singh, Murtaza Khorakiwala. Now they have come out with a totally new antibiotic. Okay, in Wockhardt. And then Sancroman was another new drug, birth control drug developed in India. And vaccines developed by Poonawalla and Bharat Biotech and all that. These are all like cutting edge work. Okay. Similarly, of course, Dr. Kakodkar, his work in nuclear reactor engineering, nuclear weapons, and now he has come out with an idea which, unfortunately, in India, people didn't take it up for research. An American startup took it up and developed a new, totally his idea of a new type of fuel which will treble the production of electricity from the same reactor. With a small modification, it will make the reactor 3 times, 4 times more efficient. And it was designed, the idea was given by Dr. Kakodkar. An American company picked it up and tested it. Now it might come back to India through American companies. And that company wanted to name it after Anil because Anil Kakodkar had given the idea. Kakodkar said, no, don't put my name on it. So they made it Anil, A-N-E-E-L, instead of A-N-I-L. It is a special thorium and enriched uranium mix, which is giving 3 times, 4 times more energy than the old fuel. Then these are the cutting edges which are still, some are work in progress like fast breeder reactor. It might come in line this year or next year. And if it does, then again in reactor technology, India will be on the cutting edge. That's it. So again, once again, I have to say, I have not mentioned the science work. Gagandeep Kang, Professor M. Sharma, Dr. Mashalkar, Rodham Narasimha, so many other scientists who have developed scientific work, or even in pure sciences or applied sciences, I have not even touched it. So that will, all of them will require a series of lectures. That's it. Thank you very much.
Thank you, sir. I think uh, maybe about 6 months back, we were thinking that there are many examples in India that perhaps to the new generation we need to tell them about them instead of going to the history and telling them what has happened, as Shivanandji has told you. Uh, so that is what has happened today. I'm sorry. I think some of the students had some programs, so we thought that way. But when you have some interesting and lecture, so that that always happens. Maybe we'll cut short what he has told. I think it's a wonderful lecture for all of us, and I should say the most inspiring one as well for all these young students who are sitting here. We'll quickly finish that, and maybe a couple of questions you can write and we'll send it to him. He can answer on your email also, because we are running. Those who will be having some shows, I think they need to go. Just will one formalities. I will request Swasji, because this program was conducted with the Association of NCSC, which is National Center for Science Communicators. So quickly, some formalities and thanking Professor Shivanand ji for that. Suhas ji.
Okay. Just, just keep some clap for me also. Okay. I think we transition from good morning to good afternoon. Did you enjoy the today's talk? Please raise your hand, those who are not enjoyed the talk. I'm very happy about it. If you enjoyed the today's talk, then please return a gratitude to today's speaker, in fact, Anybody knows who is the speaker today? Yeah, Dr. Shivanand Kanavi, in fact, Okay, may I request Anandita to come on the dais, please? Anindita, can you come on the dais? And please, from morning, he accepted the plant, in fact, like in transition, you are now grown up from transition from plant to fruits, in fact. Okay, Anita, please, may I request on the behalf of organizers to hand over the. And that was indeed a fruitful discussion, in fact, And may I request Director of Nehru Science Center, Umeshi, to hand over the memento. And I think everything will be possible, in fact. As I said to you earlier, we are just running out of the time, but we are not running out of the mind, in fact, And this lecture room were not possible. The initiative immediately accepted by the director of the Nehru Science Center, Umesh, and his leadership, I could see this hall is filling with the people in 2047, when the India complete the centenary, I think we'll be there. See the technology during that time, in fact, and thank you, Umeshi, for organizing this wonderful program. As I take pride in. He was surprised. There's no question surprised. If you like it, kindly share with the people you would prefer, in fact, That's with that, I say goodbye to you and see you sometimes back with the Shivanand Kanavi. So thank you so much. Thank you so much. And a big thank you to you also. Please clap yourself.
Some students who have time, they can just couple of those who have the show, they can quickly make out, please. Yeah, we are sorry for that, but don't forget to send your questions to us if you have any of them. You have any question? Anybody has that they have some question and they would not go back until they ask it. Otherwise, you can send it on email also, because Professor Shivanand ji has an appointment